Empezó mal. Okay. Okay, let's start just to start looking at what's going on. So have you all been able to look at the videos online? I can actually read the chat.
Yep, everything is working fine for me.
Okay, cool. Any particular questions or something?
About what you said in the YouTube video,
Yes.
about the inverse of a function when you said what was a random variable, x minus 1 of an open set AB in F. I really didn't get it.
So,
You define variable. A
okay,
function.
so you need a random variable is a function that is going from the sample space onto R. That part is okay. And then we have an extra requirement on it that it has to be measurable. So if you take the inverse, so you know, like when you take a function, the inverse, so x inverse of an open set AB, let me write it down, is equal to all the points in omega such that x of omega is in AB. Okay, so
Must have a bijection.
no, it's not a bijection. X inverse is I guess I'm doing some topology thing here that you guys are not used to seeing.
Yeah,
So
the inverse.
that is the definition of X inverse. Do you see what I'm writing? It's a
Okay.
set. So it's the set of all the elements in omega that end up in the open set AB. And so that thing here, we're asking to be an element of the measurable sets of the events.
When you say a measurable set, there is a definition of measurable.
So the definition of measurable is this.
Okay.
It's that it belongs to the sigma algebra.
And a point have a measure 0.
Depends. It depends under which measure you're taking. It depends if you're taking if you take a discrete probability measure, the value of a point can have positive measure.
Okay. I think I get it.
Okay, cool. So have you guys been able to look at the exercises so far?
I have some.
When appeared this problem in Rio with the COVID-19,
Yes.
I should travel for my city, so I have problem for time and administration to my time. So I don't have time. I didn't have time for solve the exercise, but I also know all of them.
Okay. Yeah. I mean, I definitely understand that this was a strange situation. It was even a strange situation. I also traveled this time. That's why I couldn't give some lectures last week. But yeah. Anyways, I mean, the point is that now I guess we are all stuck wherever we are, and we will have time to do this, because if not, we're going to get bored. So. I'll be around to answer any of the questions that you have of the exercises for now, and maybe next week when we meet again. So that's, I guess there's a couple of things I haven't quite figured out in the course. With respect maybe to the other courses, do you know what you guys are going to be doing with respect to exams and this kind of stuff?
What the other guys are doing?
Like what other courses are doing with respect to exams?
I think we can't do exams now, but we can do homeworks,
Homeworks.
Yeah, because I think there are problem with the Minister of Education with online exams. I don't know. I think exams for home, I don't know. It's a good idea, maybe.
Okay. Okay. Well, yeah. No, I need to think about it a bit more myself. But do you guys have any recommendation with respect to this? Something that you would prefer over other things?
I think if we have, I don't know. For me, homeworks. I learn more with homeworks than exams. So if we have more homeworks, I can do more and understand more. I don't know.
Okay, so
Well-
I just send you. I mean, you should just have gotten an email with the second worksheet class.
Yep,
Uh,
I did it. But
No.
regarding the first one, I don't have a clue how to start the exercise number 8 about the tournament. I really don't know how to start it.
Okay, so let's see.
Problem number 8
Yeah,
about
I
the
know
football.
what you're talking about. Let's see if I can find it. Yeah, let me open it. I didn't have it open. So okay, so first of all, this you understand the concept of the point that these are like playoffs in a tournament.
I believe each football team plays with other. That's right.
Okay, but the
So
point
if-
is, okay, I guess there is not enough information. I took this exercise from the previous term, so there is not enough information to finish this. But the idea is that you give more or less things. So what would be the way? So the way is you start with, let's say we take n is equal to 2 and we have 4 teams. Okay.
I tried to make it 3, but didn't work out very well.
So, I mean, this is what I have in mind that you have to have in your head. So can you see this picture?
Yep.
Okay, so the idea is that each, from this kind of tournament, you can put each team in each one of these things. And once this team plays with this team, the winner gets to this point here and the loser stops playing the tournament.
But you have an even number of players, so
You have an even number of players, and then in the next round, you have an even number of players again. So this is semifinals, this is the final, and this is the champion. And then you should think, like, how can you array out of, like, how can you array n teams in these positions? And which ones give you what you need in this case? And you should think that the probability, I mean, you should model that the probability that a certain team beats the other team is like a fair coin. It's like 1/2. So there is a 1/2 that this team will win, and there's a 1/2 that this team will win.
okay.
So, I mean, I think the first, let me see. Let me look at the first question again. So the first question says, what is the probability that 2 random teams play against each other on the first round? You need to look at, like, how many ways you can set up the first round.
I would say a combination 2 over n by 2, I imagine. Using the combination any players by 2, choosing by 2.
Yeah, I mean, you have to count how many ways can you, like, set up 2 n teams in n different games. In 2 n teams in would be in 2 to the n minus 1 games.
2? Because you have to remove the final.
No. There is at the first, in the first round, you're going to play 2 to the n minus 1 games.
Okay.
Because each game has 2 teams.
Yeah, get it.
Okay, and then you have to say, okay, if I pick 2 random teams, what is the probability that they are actually playing against each other? The question A should be fairly simple. The question B and the question C I think you need to give a bit more of information. You need to think that a team, the probability that a team will win a game will be 1/2.
And over and over and
Or
each,
excuse me?
in each game the team have 1/2 chance of winning.
Yes.
Okay.
So this should be a sort of conditional probability. Start thinking with like n, which is small, like n equals to 2, and try to see if you can figure out exactly what it is. And then try to scale it from there.
What's the probability of winning the final, given that you won the previous game, given that you won the previous game, and so on?
Yes,
So
that's like a bias rule type of thing. I mean, I would say think of it with like n, which is really small, and then try to scale from what you understand from there.
Okay, that's a good tip.
Okay. Any other questions that you guys have on exercise? I can also read any question that you can put on the chat.
I have a question about the first probability class, the video.
Yes.
You try to demonstrate some properties about the functions f of x, and then at the video, that's a frame at 43 minutes and 40 seconds. I don't know if you have the video there.
I'll open it now. But if not, I also sent a picture of the note. I don't know if I sent a picture of these exact notes. Anyways, okay. Yes, let me know.
But you say in the demonstration, if W belongs to E, that means that X of W is less than X. I don't understand that. Which E is that?
So give me 1 second. So which second you said it was?
43 minutes and 35 seconds.
Okay.
I think you write it a little bit earlier. You write it at 43:20.
Okay, I'm looking at it now. So I say W is in E if and only if X of W is less or equal than X.
Yeah.
Okay. So what is your question? Sorry, I missed your question.
I don't understand that line. So from what I get, E is like E of N means that the event that X is less than Xn. That's right?
This is similar to what I was trying to say. So you have to take the inverse of the open set. So, okay, so this is what I was showing earlier. Can you see this picture? Maybe I didn't explain this correctly. So can you see this thing? When I'm taking the inverse of an open set AB, what I'm considering is all the elements in omega such that X of omega is in AB.
Mm-hmm.
Okay, so here, what I'm trying to do is, what does it belong for W to belong to E? It means that X of W has to be less or equal than X.
But what exactly is E?
E is, okay, so didn't write E. So E is the intercept, well, okay, what I'm trying to prove is that En, let's see if I put it before. Yeah, I didn't write E. So E is the set that X of, it's the set that X of omega is less than X. So what I'm trying what I'm trying to show is that the intersection of En is equal. So what I'm trying to show is what I've written in the first line in the page at in minute 43, which the intersection of En is equal to the set of capital X less or equal than little x. The thing on the right-hand side is what I'm calling E.
Oh, I see. I think I get it now.
You get it? Okay.
Thank you.
Sure, no problem. Any other questions about lectures or something else?
That was a lemma that you gave us in class. Let AE be a family of independent events and J and K be finite disjoint subsets of I. So the probability of intersection AI J intersection, the intersection of AI complement I pertaining to K is the productory of AI J times productory AI complement K. I really didn't get it, this lemma.
So what this means, I mean, I think you should start with like just two sets. So if A and B are independent,
The intersection, probability of intersection.
Yeah, but let's go slowly. So if A and B are independent, so the only thing that we can say is that the probability, as you're saying, A intersection B is equal to the probability of A times the probability of B. Okay, but what my claim is, if A and B are independent, then A and B complement are independent. Okay, and this is something you can prove. Probability of A intersection B complement is the probability of A times the probability of B complement. That's a lemma I also proved in the same class.
Yeah, exactly.
Okay, but now you do the same thing with a sequence of events. So let's say that we take A1, A2, and A3. What I'm saying is A1, A2, and A3 are independent, is equivalent, or I mean, is equivalent. It's the same as A1, A2 complement, A3 complement are independent, or A1, A2, A3 complement are independent, and so on. Okay, so if you have three sets that are independent, then a set with the complements are also independent, or two sets and then one complement are also independent. So the notation there is that you just take a subset of how many elements you have, and you take another subset, which is disjoint from the first subset. And now if you consider the sets AI in this first set and AI and AJ complement of the second set, all of these events are independent.
Does it work when an infinitive sets A1, A2, A3 to the infinite?
It does work. It does work with an infinity of sets, but the definition of independence is that they have to be that the probability of finite intersections is the product of the probabilities. So it works for like an infinite amount of sets, but you only have to check the definition of independence for finite intersections.
Okay.
Okay. Okay. So yeah, if you have a question on the chat, you can just put it in and I can answer it. Any other questions? Something about the exercises or? So, because I mean, there is another idea. The other idea of like teaching is like for me to teach live on something like this, and then check if this is better. Like, do you prefer like the YouTube video versus like a live?
I really like it, the YouTube video form.
I really like I like the YouTube too.
Okay. No, that's fine. I mean, usually if I teach or even over something like this, the video can be recorded anyways. I'm recording this thing right now. I guess I should tell you. And so I can add it on YouTube so you can actually, guys, look at it if you have if something I said was not clear. Okay, so I guess Felipe is asking me if I can explain question number 9 in the exercises. So I guess question number 9 says, let me look. So question number 9 says, n balls are randomly and uniformly and independently placed in one of n different boxes. So, okay, so the question is there a probability that of one box is emptied? So the point is, you grab each ball and put it in a random box, okay? So let's say I have 2 balls and 2 boxes. I grab the first ball, I can put it in either of the boxes. I put it in the first box, so that with probability 1/2. Then I grab the second ball, and I have the same probability of putting it in the first box or in the second box. So I can put the second ball in the first box as well. Okay, is that clear? What I'm trying to say is you could, I mean, if you have n balls, you can put the n balls in the first box. That has probability 1/n to the n, which is really small, but it's still possible. Okay. So, I mean, I guess, yeah, that's a fairly reasonable way of explaining that. Any other questions or something you want to ask? Yeah, I need to think a bit more about the exam. Because, I mean, honestly, what I was thinking, but I'm not sure, maybe homeworks are better and I'll just grade the homeworks. But what I was thinking is giving them, like, basically chatting with you through Zoom or something like that, send you the file of an exam and then give you like 2 hours to do it or 3 hours to do it, and then you send me a PDF back. That seemed fairly reasonable to me, but I'm not sure, as you're saying, that like if the Minister of Education is okay with that or not.
The other courses, I believe they will do tests after we go back.
There is no going back. There is no going back. I'll be surprised if we go back before the semester ends. So can we take a review class? Yes, definitely. I don't, the question is still when would the exam actually be? I'm not exactly when the exam will be because I have to figure out, but yeah, before the exam we'll do a review class. And also I'll try to get in touch with the person that was supposed to do your monitorías and see if she is able to give you a review class as well. So then you have a different perspective and somebody that speaks Portuguese instead of somebody that's speaking English to you. By the way, I should, when the exam was planned, let me see, I wrote it somewhere. I don't remember. It was like the 20th of April, something like that.
So we can maintain this date or 2 weeks later, maybe, I think.
Yeah, no, I mean, honestly, I would, whatever, I mean, it's not that I have an exam already planned. Whatever it will be on the exam will be the topics covered until the moment. So I know we have lost some time, so I won't actually make an exam as I was thinking with the same things. Usually whatever I have covered in the last week before the exam or something like that probably won't be in the exam. So it should be like things up to like the beginning of April or something like that. So it's not much of an issue. Okay, is there something else? No, honestly, this is the first time I'm teaching something online, so I'm not completely clear of what to do. I think the YouTube videos are a fairly reasonable solution, and as you say, I mean, it's good because you have time to think and you have time to stop and you have time to make things. If you have questions of specific things in the YouTube class, you can send me an email with your questions. So feel free.
I'd like to know if there is a possibility of some answers to the worksheet. Because, for example, when I tried to do this number 8 of the worksheet 1, I had 3 different answers and I didn't know what answer was correct. And
yeah,
each one
I never took the time of writing these solutions. No, so what I will do is I'll right now, I was supposed to do it this morning, but I forgot. Get in touch with the person doing the monitor that was supposed to do the monitorías. And with her, you should be able to get a more straight answer than just like a waving hands like I'm giving you.
Okay.
So she should be able to check if your solution is correct or not and this kind of stuff. That, I mean, and also, I mean, I imagine she can take like sort of Zoom meetings like this and you can actually ask specific questions. Okay. Any other questions or something that you want me to go over?
No, for me it's okay.
Anybody on the chat that has something to say? Can you do number 4? Which one is number 4? Can I do number 4? Good question. Okay. So given events A and B, such that the probability of A is 2.5 and the probability of B is 4/5. Show that the probability of A intersection B is between 1/5 and 2/5. Can any value in the probability of A, can any value be achieved by probability of A intersection B? Okay, so what do we have? So we have omega, we have A, we have B. Okay, so we have a picture like this. And now, so morally, what I would do is take F, which is equal to the smallest sigma algebra containing A, B, and the complements. So it should be empty set A, comma B, A intersection B, A minus B, B minus A, and A union B, and omega. Okay. So does everybody know what exercise I'm trying to do? So I'm trying to do exercise number 4, in which you are given that probability of A is equal to 2/5 and probability of B is equal to 4/5. Okay, so what you need to do is create a probability. So create a probability triple, which would be omega, the set of events F, and a probability P. Okay, so P is a function that is going from F to 0, 1, such that P of omega is equal to 1, and P of, let's call it E1 union E2 is equal to P of E1 plus P of E2 if E1 intersection E2 is equal to the empty set. Okay, so morally what I need to do to like figure out this exercise is I need to give value to each one of these sets. Satisfying the properties P of A is equal to 2/5 and P of B is equal to 4/5. Okay, so what are the restrictions that we have? We have that P of A intersection B plus P of B minus A has to be equal to 4/5, which is P of B, and P of A intersection B plus P of A minus B has to be equal to 2/5, which is equal to P of A. Okay. So now, what do I need to do here? So if you sum this up, what do you get? And then, okay, so here I'm missing the complement, A complement intersection B complement. It should be something like this. My probability space, my set of events should contain all of these guys. So how do I do this? Okay, so the first question is that P of A intersection B is between 1/5 and 2/5. Okay, so how do you do the following? So P of A intersection B is less or equal than P of A, which is equal to 2/5. That's one of them. And the other one of them is how do I show that this is less than 1/5, bigger than 1/5? P of A union B is equal to P of B minus A plus P of A intersection B plus P of E minus A. So it's equal to P of A plus P of B minus P of A intersection B. Okay, so the way that you get the both inequalities is by doing the following. So to get both inequalities, one of the inequalities follows from P of A. So P of A intersection B plus P of A minus B has to be equal to 2/5, which is P of A. Okay, and that implies that P of A intersection B has to be less or equal than 2/5. And the other one, the fact that P of A intersection B has to be larger than 1/5 is because P of A plus P of B is bigger than 1. So you have that 1 is bigger or equal than P of A union P of B, which is equal to P of A plus P of B minus P of A intersection B. And that's how you get that P of A intersection B is equal to 1/5. Now for the other part, you need to come up with a function given values specifically to each one of these sets. So let's put it like this. So for the other part, you need to give values for each one of these sets such that all of them sum to 1, and the sum of this part with this part is equal to 2/5, and the sum of this part and this part is equal to 4/5. Okay, so let's call it lambda 1, lambda 2, lambda 3, and lambda 4. Okay, I'm not sure you can look at this thing here. So now you have to find, so lambda 1 is the probability of A union B complement. Lambda 2 is the probability of A minus B. Lambda 3 is the probability of the intersection. And lambda 4 is the probability of B minus A. Okay, and the conditions that you're going to have is lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 is equal to 1. Lambda 1 plus lambda 2 is equal to 2/5. And lambda 3 plus lambda 4 is equal to 4/5. And then lambda 1, lambda 2, lambda 3, and lambda 4 have to be all bigger or equal than 0. Okay, so to check if you can actually find solutions, find every value in the interval, you need to check if you can find a solution of this where lambda 2 is between 1/5 and 2/5. And sorry, this is this is lambda 2 plus lambda 3. And yeah, this is lambda 3. Okay, so the only thing that you need to check for this to be true is you need to check that these conditions can be satisfied with lambda 3 being between 1/5 and 2/5. Okay, and the point is that this has they all have to be positive. Does that help with the question? Okay, any other questions, exercise you like to for me to go over?
No. Okay.
Yeah, I mean this time, I will try to make the lectures available early next week, maybe even tomorrow if I'm. I cannot leave the apartment anyway, so. But I'll try to make the lectures available, and then I'll set up this same time next week, so that you guys can ask any questions about the exercises or about the class specifically. That should be what we're going to be doing for the next couple of weeks at least.
Okay.
Okay.
Okay. That would be fine.
Sounds good. And yeah, as I said, if you have some questions about some exercise or some or something like in the lectures, just drop me an email and can try to answer it. Okay.
What's your email?
My email? So it's my name. So I'll write it in, let me try to write it. So my email, you can send it to the book one, but this one I get right away. Okay. And I'll try to set up later today for you to have a Zoom meeting with the other with the monitorias, so that somebody that actually cares about the exercises can give you a bit more of this thing. All right. Any other questions or something?
No.
All right. Well, if you have any question that comes out later, let me know by email or something, and I can try to answer it. If not, enjoy staying at home.
Actually, I have to work.
You have to work. Yes. You're
Yes.
actually trying to save the world, no?
A piece of the time at the time.
A patient at a time.
Yeah.
Okay. Keep up the good work and try to stay healthy. I guess it's bad time to be a doctor right now. Oh well. Anyways, I'll see you next week, guys, and I'll send you the email with the class soon. Okay.
Okay.
Thank you.
All right. See
Thank
you guys.
you.
Bye.
Okay.
Bye bye.
Okay.